Okay guys, we got a 4.3 liter L99 V8. Who's ready for some nitrous? In this video, we're gonna run a low buck plate sniper nitrous system on our Junkyard 4.3 liter L99 V8. You know, the baby LT1. We're gonna run 3 different jet sizes and step the power up. So let's start off by running the motor NA, then add some nitrous. As we've shown in the previous video, we have our 4.3 liter L99 Caprice Classic baby LT1 V8 up on the dyno, and we've run it with a GM Performance Parts dual plane intake manifold, a HOlLEY 650, and we have our dyno headers on there, which are the headers that we run on basically every small block. And even though the outer bolt holes that they use for the LT1 are different, it has the inner holes too, so we can bolt on any conventional header. So run in carbureted trim, our otherwise stock Junkyard 4.3 liter L99. This combination produced 243.5 horsepower and 280.9 foot-pounds of torque. See, it's got a nice torque curve. It's got good power, especially for just being a 4.3 liter and being saddled with a stock cam and stuff. It'll be interesting to see how much power the factory LT1 intake manifold adds or subtracts away from this dual plane. The combination really liked this dual plane, and we were going to run nitrous on this combination, which was really cool. I was excited about that because this was carbureted. It's very easy to add a simple plate nitrous system, which is exactly what we had. And since this was a low-dollar Junkyard motor, we were adding an equally low-dollar nitrous kit. This was a sniper kit from the guys at NOS, and it's priced pretty affordably. It's adjustable, you know, within a certain range, and it's easy to add 100, 125 horsepower with this kit just by changing the jets. But we did an interesting test before we got the nitrous on there, and this is one thing that a lot of people don't realize, because this will affect any combination, basically anything that you put a plate system on. It's going to affect a dual plane combination a lot more than the single plane, but it can also affect a single plane. But on our dual plane combination, when we put the nitrous plate on there to obviously inject the nitrous, the plate by itself had a significant effect on the power curve of this combination. And typically when we put an open CARB spacer on a dual plane intake manifold, what happens is it kind of puts it in that intermediate range between a dual plane and a single plane. It's not quite a dual plane because it has an open divider now. And it's not quite a single plane because it has the rest of the combination is basically a dual plane manifold, but it does hurt the signal when you put an open spacer in there, especially down low. And typically what happens is you have a drop in low speed power with an open spacer on a dual plane, but it picks up power at the top. So it transitions. This is why Edelbrock did their RPM air gap with a notch in there. It's the same kind of thing. And that's kind of what we expected here. Unfortunately, that's not what happened. So here's what happened when we ran the motor with the spacer with the nitrous plate. Just adding the nitrous plate under the carburetor. and that's in red. So we had dramatic effect in power. The power jumped down to 235 horsepower, so we lost almost 10 horsepower, and we lost it through almost all of the curve, not quite much down here at 3,000 RPM, but we certainly lost a lot of power, and when I say a lot, it's relatively speaking, 10 or 11 horsepower is a lot when you're only making, 240, so it's a significant percentage. But this was an interesting test, just putting the spacer on there, and it did not do what it normally does. When we put the spacer on there, we even had to change jetting, because when we put the spacer on, it was a lot leaner than it was without, and that's normally the case because it reduces the signal to the carburetor. So a reduced signal draws less fuel. It basically needs bigger jetting in that, and that's exactly what we did. We jetted this thing up, and this was as this was as close as we could get to the original output just running the dual plane. So on this little 4.3 liter, it really liked the dual plane. It really liked to be divided and didn't like the spacer so much. But luckily, the spacer comes with, something a little extra in the form of nitrous. But we're also going to talk about that because there was another drop in power. So let's get to the nitrous. So here's our combination again. This is with the dual plane intake manifold and then what happened after we added the spacer. But take a look, and I'm going to go over all the nitrous hits by themselves, but I just want to introduce this one thing so we can talk about the power loss associated when we're doing nitrous. Obviously, in this case, the plate by itself definitely reduced power. But here's what happened when we put our smallest nitrous jet on there, and we'll talk more about the power output in just a second. But I want you to take a look at this loss in torque here, because none of this is on the nitrous. This is basically just a naturally aspirated run before we activate the nitrous, and the power is way down even from the running the combination with a spacer. And the reason for that, and it's something we can easily cure, but we have a locked distributor, so all we did was retard the timing for the nitrous. In this case, we took out about 3 degrees. But we got a loss in power from that 3 degrees. Now, if you had the ability to dial in the curve at every RPM range like you do with EFI, or if we had a distributor that had an advanced mechanism in it, we could put this timing back in here and have it come on later, and we could adjust that. But the point is that because we retarded the timing, we took another loss of, in this case, 269, 253. So it was like 13 or 14, 15 foot-pounds of torque. So it's another big hit, and what happens is we've got to work our way back up out of that hole with the gains from the nitrous. And lucky for us, we can have some fairly big gains on the nitrous. But I wanted to point that out. So we lost going from our normal combination with the dual plane and the carburetor. We lost putting the spacer on there. And then we also lost from taking the timing away. And normally if you just take the timing away on the nitrous hit, like a lot of guys do, they'll program it so the timing just comes away after nitrous activation, which is a good way to go. Then you don't experience this loss. But because we had just a distributor that we mechanically turned and took the timing away, this was the result. But I just wanted to let you guys know when we talk about the nitrous power, this was part of it. So let's get to our nitrous. This is the Westech bottle heater. Get the bottle up to temperature, get that pressure up, so you get good nitrous feed. This is nice because it's a water bath, lots of thermal mass. We just plug it in over there, turn it on. This thing can get up to 110 degrees if we want. If we let it, we usually don't let it get that high. But we can get the bottle up to, around between 93, 95 degrees or so. That gets the pressure up to where you want it, so we get good nitrous flow to the motor. Got our fancy timing pointer, so retard the timing. All we did was turn the distributor to retard the timing. So it's retarded all the time, including when we activated the nitrous. we'll start our baseline with our run made with the spacer plate, because that's kind of our new baseline. It made 235 horsepower and 269 foot-pounds of torque. And here's what happened after we added the sniper plate nitrous and actually activated the nitrous. We had a 42 nitrous jet in there, and that increased the power output from 235 to a peak of 312, although it leveled off to where our difference was 295 and 231, more like 60 or 70 horsepower. But remember, part of that is because we had a drop in power from our drop in timing, which was about 3 degrees, as I said, on this combination. So now let's take a look and see. And we did what most guys do, just like what you do with boost. You add boost to make more power, and we added nitrous jet. In this case, we put a 46 nitrous jet, and we stepped up the fuel jet accordingly. So the red now is the 46 jet, and the blue is the 40 jet. And if this is getting too busy, what I'll do is I can get rid of torque. So we're just looking at horsepower. So it's a little bit easier for you to take a look at. But as you can see, we gained by going from that jetting 300 to 320. So that picked us up another 20 horsepower or so, which was good. And again, because we added the nitrous and then increased the jet size and we picked up power, you know, what are we going to do now? Well, obviously we're going to go up in jet size again. So what we did was replace the 46 nitrous jet with a 53 nitrous jet. And as I said, each step up, we also stepped up in the fuel jet as well. We ended up running a 39 fuel jet with the 53 nitrous jet. So in this case, the power jumped up to 354 horsepower, although, you know, it tapered down like the other ones did. But it was more than 100 horsepower gain with the 53 nitrous jet. And this combination worked good. I mean, this thing took the nitrous without any problem. It seemed like it was happy. We still only had 3 degrees. All of this was run on pump gas. This thing wanted to run best NA between 29 and 30 degrees of total timing, and all we did was retard that by 3 degrees all the way for all of these nitrous sizes. We didn't reduce the timing or retard the timing anymore when we added more nitrous. We didn't add a ton more, but as you can see, we did pick things up a little bit. So this is what's available with nitrous with any kind of combination. This was cool that we did it on this 4.3 liter V8, but this is what happens when you do nitrous. And on other combinations, I think you'll get even bigger gains from that kind of a spread. This thing worked out really well. Let's get to our conclusion. Real quick before we get to our conclusion, I just wanted to show you guys also the torque curves. It looks an awful lot like the horsepower curve. You know, we see when we increase the nitrous size, we picked up more and more torque each time, and we hit it at about the same RPM. We had big spikes, one of them 393 foot-pounds of torque, so almost 400 foot-pounds of torque on the spike, but we don't usually count that. Obviously, the torque is falling there, but the horsepower is staying fairly flat when you activate the nitrous like that. But this is kind of typical, you know, kind of railroad tracks, which is nice. Nitrous works really well on a carbureted application. Also works on EFI stuff, which we might show that as well after we put the LT1 intake manifold back on here. We can run a single fogger setup in front of the throttle body and have nitrous go into that intake manifold. The distribution should, I think, be fairly good on the LT1 intake because it's a big common open plenum with short runners, so that should lend itself to being have good distribution. But the only way to find out is to run 802 sensors on there. We're probably not going to do that because it's always fairly safe to hit something with a 100 shot, even if it has you know, questionable distribution. Now we can get to our conclusion. Okay guys, as you can see, our 4.3 liter L99 baby LT1 responded to nitrous the same way really every other motor responds to nitrous. I mean, every motor loves nitrous, just like every motor loves boost. So if you apply a 75 shot to a motor like this, or really any other motor, it adds 75 horsepower. The same thing with a 100 shot or a 125 shot. Nitrous works awesome, and it does so even on a Junkyard 4.3 liter V8. So what's coming up now for our L99? I'm glad you asked. Now that we've done the easy button with nitrous, we need to look at other ways to make power. And yes, I'm thinking boost, but we're not going to do that right now with this motor. Boost is coming, but that's down the line a little bit after we make more modifications. So now we need to look inside the motor. I'm talking specifically about camshafts. So in the next video, that's what's coming up. I've got the camshafts from TPIS. We're going to upgrade the valve springs. Then we're going to try 1 or 2 different camshafts, mild versions for this 4.3 liter. Then I have a little surprise. I have another test that I haven't told anybody about for our L99. Thanks for watching, guys. Make sure to like, share, subscribe, ring the bell, do all that stuff. More L99 testing coming up.